Today we're going to talk more in depth about plate boundaries and tectonics, so how our Earth is broken up into plates in the outermost layer of the lithosphere. So we know from before that the layers of the Earth consist of the core, the mantle, and the crust. But more specifically, now the difference between the crust and the mantle, that has to do with compositional differences. So it's literally made of different stuff. Versus the lithosphere and the asthenosphere, that's a physical difference in that the lithosphere is rocky. Okay, it is rocky and it is brittle. Versus the asthenosphere, that is putty. It's a putty-like substance. And the lithosphere itself rides atop that asthenosphere, and you can think of the lithosphere as the plates. The asthenosphere is what it floats in. So deep within the Earth, we have what's called convection, and that's mixing through movement. Okay, so what's happening is that within the Earth, in that putty-like asthenosphere, you've got differences in temperature and density, and this causes movement within the Earth. Okay, so we've all seen lava flowing before and from volcanoes in like Hawaii. Imagine that mixing happening inside the Earth, and that outermost layer of the crust, that lithosphere, floats on top of that and then is moved by these convection currents. So if you've got these cells of convection happening within the Earth, what those will do is those will push on the slab of the lithosphere up above, and they will cause the plates to move, albeit they're moving really, really slowly, about the same speed as your fingernails grow. So we've got our tectonic plates, which are large-scale breaks in the lithosphere, so that we have these slabs of lithosphere happening all over the Earth. Some are huge, like the Pacific Plate or the North American Plate, and some are really, really tiny. If you look at something like the Caribbean Plate there. Now, to understand how plates interact, we got to know the difference between continental and oceanic crust. And if you look at this map of crustal thickness throughout the world, you can see that continental crust is very thick, and this is less dense. Versus ocean crust, this is much more thinner, and it is more dense. So if you can see right here, this is ocean crust. Continental crust is right here. And it gets thickest at places like mountains, like the Himalayas there. And if we talk about something called isostasy, that's how something floats. So we see that something that is thinner and more dense is going to float a little bit lower in the water there, versus stuff that is thicker and more dense will float higher in the water, but also lower down below. So crust gets much thicker where there are mountains being built, so like in these areas, and it not only goes further down into the asthenosphere, or the mantle as it shows here, and higher up. So we've got what are called active or passive margins. So an active margin, if you look at something on a continent, is where you go from one plate boundary to another. So if you look here, like that Pacific Ring of Fire, you can see that we go from continent to ocean crust at a plate boundary. But there are places like the coast of Maine where we don't have a lot of earthquakes, we don't have a lot of volcanism, where we have what's called a passive margin. And this is where you transition from continental to ocean crust without a break in the lithosphere. So understanding passive plate margins is important because it tells you about the sovereignty of different waters and where it's legal for you to do things like fish or to claim areas as your own. So you can see there's lots of different special determinations here where it talks about the exclusive economic zone, the rights over natural resources of the seabed and subsoil. And this is something that's important when it comes to trade, comes to oil, any number of different things. But what we care about most right now are those active plate boundaries. So you're going to see cross-sectional and map views, where a cross-sectional view is where you would cut into the Earth, and you can look at it from the side. So you can see what's happening up above and down below. And we see that the first type of boundary we're going to talk about is divergent. So if you have a divergent boundary, we see that plates move apart. So when plates move apart, on a continent, you'll create something like a rift valley, like here in eastern Africa, where these two plates move apart and magma rises up from the asthenosphere to create new lithosphere here. Versus if you look at something in the ocean, the same thing can happen with ocean crust moving apart. This is something like the Mid-Atlantic Ridge, where the Atlantic is getting bigger and bigger every day, and as these two plates diverge, new asthenosphere comes up and freezes to make new lithosphere. The next type of boundary is what's called a convergent boundary. So convergent boundaries between something like continental and continental crust, this happens when they move together. So these two pieces of crust are moving towards each other. And when that happens, you can imagine that these plates crumple up and they get thicker. So one great example of this is where India is actually cruising and hitting into the Eurasian plate there, and is creating the highest mountains in the world, the Himalayas. Because these two plates are of basically equal density, they don't ride under each other quite as much as some of the other types of boundaries will, and instead they'll crumple up the land quite a bit more because they're relatively the same density. Versus if you've got convergent boundaries happening between oceanic and continental crust, we have to remember that with continental crust, this is less dense versus this is more dense. So what you'd get is something called subduction. And subduction happens whenever one plate is forced beneath another one and has to then go and travel down into the asthenosphere. So what we would refer to this area as is a subduction zone. So whenever continental crust and oceanic crust meet and their two plate movements are converging, meaning they're going towards each other, you will see that the ocean crust will be forced underneath that continental crust. And what can happen is volcanism as a result, where this plate doesn't necessarily melt, but it releases gases and volatiles and water into the asthenosphere right here, which causes melting and then creates volcanoes that happen along these types of boundaries. So an excellent example of this is something like the Andes Mountains. So this is one giant subduction zone, so that's why there's all these huge mountains happening in these areas. If I was to show this in map view, so say I've got point A here and point B right here. I'll redraw A and B like so. You'd see that it's this line that separates those two plates, and you've got ocean crust over here, and you've got continental crust over here. And what I would do is I would then show these little triangles here. And if I had hours, I would even fill them in, which shows that this plate here is going underneath this other plate. You can also have convergent boundaries happening, finally, with oceanic and oceanic crust. So this is a kind of case where one of these types of ocean crust happens to get subducted beneath the other one. You get volcanism happening, but it's building up from the ocean floor, and it makes places like the Great Aleutian Islands here. Finally, the last type of boundary is what's called a transform boundary. Now, this is when two plates are not moving towards each other nor away. Instead, they're moving past each other, and they are creating what are called strike-slip faults. So a classic example of this is the San Andreas in California, where you get tons and tons of earthquakes associated with the friction of these two plates just moving past each other. You also happen to get these things out in the deep ocean here, where if you see what is actually a divergent margin located here, but separated by little transform faults that kind of go and feather off from these boundaries on either side there. So it makes these kind of like little ladder-like features, stair-like features, I should say. And that should be about it for plate boundaries. Thank you very much. Take care.